we are moving on. We're actually going to skip lesson 20. So we're going right to 21, which is an exercise in changing scales. So we have Jake. He reads the following problem. If the original scale factor for a scale drawing of a square swimming pool is 1/90, and the length of the original drawing measured to be 8 inches, what is the length on the new scale drawing if the scale factor of the new scale drawing length to actual length is 1/144? So he works out the problem. He takes 8 inches divided by 1/90 to find out what the actual length is. He gets 720 inches. And then he takes 720 inches times the new scale and gets 5 inches, which would be the new scale drawing length. And we want to know if he is correct. Yes. So again, he took the original scale drawing length divided by the original scale factor to get the actual length of 720. Then to get the new scale drawing length, he takes the actual length of 720 times the new scale factor and gets 5 inches. So,
Mrs. Anthony?
So we're looking to find what the scale factor of the new scale drawing is the original scale drawing. So the scale for the second one is 1/144. The first one is 1/90. So we take 1/144 divided by 1/90, excuse me. Lots of fractions today. And we get 5/8. That's basically the ratio. So still with the same problem, using the scale, if the length measures 10 centimeters on the new scale drawing, using the scale from the first problem, 1/144, find the actual length of the pool in meters, and then what is the surface area. So first we need to convert 10 centimeters into meters. Okay, so we have 10 centimeters equals 0.1 meters. Then we're going to take 0.1 divided by 1/144, and we get 14.40 meters. If you remember, it's a square swimming pool, so we take both our measurements are 14.4. So 14.4 times 14.4 gets us 207.36 meters squared, but it wants us to round to the nearest tenth. So we have 207.4 meters squared for the surface area of the actual pool. Okay, so try this one on your own. It is a little difficult, but that's okay. Challenge is good. So I'll read it for you and then you can pause and work on it. Ronald received a special toy train set for his birthday. In the picture of the train on the package, the boxcar has the following dimensions. The length is 4 5/16 of an inch. The width is 1 1/8 inches. The height is 1 5/8 inches. The toy boxcar that Ronald received has dimensions: length 17.25 inches, width 4.5 inches, and height 6.5 inches. If the actual boxcar, meaning the real life-size one, is 50 feet long, find the scale factor of the picture on the package to the toy set, and then find the scale factor of the picture on the package to the actual boxcar. So just take a crack at it, see how you do. When you're ready, hit play and we'll go through it together. So, to find the scale factor of the picture on the package to the toy set, we take the length of the picture divided by the length of the toy boxcar, and this is just written out for easier math, and we get 1/4. So the scale factor of the picture on the package to the toy set is 1/4. Then we want to find the scale factor of the picture on the package to the actual boxcar. So we're going to do the same thing. We'll take the length of the picture divided by the length of the boxcar, which it's in feet, so that's why we have the 12 to make it in inches. So we get 4 5/16 divided by 600 inches. Then again, we simplifying to make it easier. So the scale factor of the picture on the package to the actual boxcar is 23/3200. Okay? So We have a couple more questions now. So now that you know for sure what those two scale factors are, you're going to use them to find the scale factor between the toy set and the actual boxcar, and then find the width and the height of the actual boxcar. So again, hit pause when you're ready, hit play to see what the answers are. So we're going to take the scale factor from the picture on the package to the actual boxcar and divide it by the picture to the toy set scale factor. We get 23 over 800 for the scale between the toy set and the actual boxcar. Okay, now that we know that, we're going to take the width of the toy divided by the third scale factor to get 13.04 feet, which is the length or the width of the actual boxcar. And then we're going to take the height of the toy divided by that third scale factor, and we get 18.84 feet for the height of the actual boxcar. So again, I know that one was really tricky. That's okay. Sometimes we need a little extra challenge just to see where we're really at. Okay, so there is no assignment for today, but we will be taking a test tomorrow. So there will be a review like there was halfway through the unit, but you definitely can start reviewing now, whether it be watching a video from one of the old lessons that you maybe struggled with, or just going on IXL and reviewing some of those skills that you worked on earlier in the unit. Okay? If you have questions, let me know. But otherwise, have a great Wednesday.